All right, with this one, what it's asking for is it just wants the area of one of these cross sections. So just this one right here. So if I want to find the area of that cross section, first of all, I need to know what this height is right here. So that height is actually going to be this one right here is going to be this function right here. So I need to solve this for y. So in other words, I'm going to subtract x squared to both sides. So I get y squared equals negative x squared plus 1. Then square root both sides, so you get y equals the square root of 1 minus x squared. Now, I'm just going to do the positive. I'm not going to do plus or minus, because plus or minus will give me the whole thing. But I only want to deal with this, and then I'm just going to double that. So if I take this triangle, so if I have this triangle, pretty much what I just did was I did this one right here. So this part right here is the square root of 1 minus x squared. So what I need to do is I need to find the area of this triangle. Now the area of an equilateral triangle is s squared, square roots of 3, all over 4. Where if you have an equilateral triangle, this is s, and this is s. So in our situation, s is going to be 2 of these. So if I plug that into this equation, I end up getting the area of this one piece is going to be s squared, so that's going to be 2 square roots of 1 minus x squared, square roots of 3 all over 4. So if I multiply this out, I end up getting 4, and then the square root squared is just 1 minus x squared, square roots of 3 all over 4. This 4 reduces with this 4. So the area of this one triangle is going to be 1 minus x squared multiplied by the square root of 3. That's just one area. Now that's what the question is asking. Now if you wanted to keep going and finding the volume of this whole thing, what you would do is you would just take the integral of the square root of 3 from negative 1 to 1 of 1 minus x squared dx, and then just take that integral, and that'll give you the volume.